This is GATE 2016 set 1 question for 2 mark. A G is an undirected simple graph. Okay, now simple graph means it can be a graph like this. It will be not having any loops. For a simple graph, the only condition is it should not have loops. It can have cycle, but it should not have loops. Okay, self loop like this. It is not allowed. Cycles are allowed. In which each edge has a distinct weight and E is a particular edge of G. Which of the following statements about the minimum spanning trees of G is or are true? Okay, so two statements are given with respect to this and they are having distinct edge weight. All the edges are having distinct edge weight. First statement, if E is the lightest edge of some cycle, if E is the lightest edge of some cycle, then every minimum cost spanning tree of G includes E. Okay, now let us try to draw the minimum cost spanning tree for this. 1, 2 and 4. 3 will form a cycle, so 3 will not be the part of your minimum cost spanning tree. Now E is lightest for this, it will get included. This E is lightest for this, but it is not a part of minimum cost spanning tree. This we have already seen in observation that lightest may or may not be the part of minimum cost spanning tree. Now what about the heaviest? If E is the heaviest edge of some cycle in G, then every minimum cost spanning tree excludes E. Okay, so now see here 3 is the heaviest and 3 is not present here. Then for this 5 is the heaviest and 5 is also not present. So second statement is a true statement, first statement is a false statement. Therefore only statement 2 is a true statement. This we have already seen in the observations. This is GATE 16 question. It is from set 1 again. Okay, if you remember, we have already seen one example from set 1 and this is a 1 mark question. Okay, so in GATE 2016 there are number of questions basically from the minimum cost spanning tree topic itself. So what is the question? Let G be a weighted, connected, undirected graph with distinct positive edge weights. If every edge weight is increased by same value, then which of the following statement is or are true? Okay, this is GATE 2017 question. It is a 2 mark question. Let G be any connected, undirected, edge weighted graph. The weights of the edges in E are positive and distinct. That are the characteristics. Consider the following statement. Which of the above statement is or are necessarily true? The first statement, minimum spanning tree of G is always unique. Okay, now let us draw one graph which has positive distinct edge weights and let us draw the spanning tree. So what they are saying is the minimum cost spanning tree is always unique. Okay, if the edge weights are distinct, the spanning tree will be definitely unique because there is no repetition. If there are repetition, then there is a possibility that you will get more than one spanning tree. So here there is no repetition, so definitely the minimum cost spanning tree will be unique. So first statement is true. Second, shortest path between any two vertices of G is always unique. Now see, shortest path, the path from this point to this point. Okay, it can be either this, that is 1 to 2, or it can be directly 3. So there are two paths, 1 to 2 or directly 3, because both are same cost, 3. So two paths exist between two same point. Therefore the second statement is false. It is not unique. The shortest path is not unique. The shortest path can be 1, 2 or it can be 3. So only true statement is first, second is a false statement. This is GATE 2016 question. Let G be a weighted, connected, undirected graph with distinct positive edge weights. If every edge weight is increased by same value, then which of the following statement is a true statement? So first, take one graph which has distinct edge weights. Okay. So this is the graph I have considered where all the edge weights are distinct and it should be connected. That is the only condition required. Now first what we have to do, we have to draw second graph where we have to increase this age weights by some constant value. So all age weights should get increased by same constant value. Let us consider I am increasing by 2. So all age weights should get increased by 2. So this is my G dash. Okay, same value. Then which of the following statement is true? Now we have G and G dash. With respect to that, we have two statements. First, minimum spanning tree of G does not change. So first draw the minimum spanning tree for this. 1, 3, 4, 2. Okay. 7 will not be the part of a minimum cost spanning tree because it is forming a cycle and heaviest weight will never be a part of minimum spanning tree. Similarly, let us draw for this T dash spanning tree. 3, 5, 6, 4. 9 is the heaviest age weight, so it will not become a part of minimum spanning tree. So you can see the structures. Both the structures are same. Okay, so you are getting the same minimum cost spanning tree for G as well as G dash. So therefore, the first statement is a true statement. Now see what is the second statement. Shortest path between any pair of vertices does not change. Okay, so let us consider the shortest path between these two points. Here the shortest path is 7 plus 2, 9, 3 plus 4 plus 1, 8. So shortest path is this. 8 is the weight total cost. This will not get preferred. Now let us see for G dash, which is the shortest path between same point again. 9 plus 4, 13, 5 plus 6 plus 3, 14. Okay, the sum of this is coming to be 14 and this is coming to 13. So which path will get selected? This path will get selected. Now see here, the path is this. Here the path is this. So shortest path is changing. So shortest path is not same. So second statement is false. Only first statement is a true statement. So therefore, correct option is